So good morning dear students. As we are doing the topic that is practical problems on maxima and minima, let's get started with this. Okay, here we have the question. It says the sum of the perimeters of a circle and a square is k. You are given a circle and a square and their perimeter, that means perimeter of this and perimeter of this is equal to k, where k is a constant. Prove that the sum of their areas is least when the side of the square is double the radius of the circle. We have to prove that their sum of their areas, that means the area of this circle and the area of this square, this is least when the side of the square is double the radius of the circle. Let us consider the side of the square be s and the radius of the circle be r. Means we have to first we have to prove their sum of their areas is least and the side is double of the radius. These things we have to prove. So let's get started. Given perimeter of circle is what? This is nothing but the circumference of the circle. So 2 pi r plus what is the perimeter of the square? Let us consider that as s, the side be the s, edge which is equal, the perimeter of square will be 4s. I'm not writing let the radius of the circle be r and the edge of the square be s. I'm directly starting, as you can write those steps. Okay, so prove that the sum of their areas, this is given to us. What will be the sum of their areas? That I'm considering a, and the sum of the areas will be area of circle is pi r square plus the area of the square is what? S square. When the side of the square, that means we need to differentiate this equation with respect to the side, that means dA by ds. As we'll get first we need to replace r here. Okay, we need to replace, so we are replacing r here. How we are replacing the r? With the help of this equation. Okay, so from here just take this 2 pi r that side, so k minus 2 pi r, what will be s will be k minus 2 pi r upon 4. Okay, so sorry, we have to replace r, no, take 4s that side, so 2 pi r equal to k minus 4s, or r is equal to k minus 4s upon 2 pi. Now put the value of r in this main equation. So a will be equal to pi bracket k minus 4s upon 2 pi the whole square plus s square. A will be equal to pi k minus 4s the whole square upon 4 pi square. Okay, this will be 4 pi square plus s square. You can cancel one pi, so finally we'll get k minus 4s the whole square upon 4 pi plus s square. This is your a. Now differentiate this equation with respect to x, s, sorry, not x, s. So s. Okay, so now dA ds will be equal to 2 times of k minus 4s into k. Differentiation of k will be 0 minus 4s. Okay, whole upon 4 pi plus 2s. Okay, so now what you can do, you can cancel this. Wait, no need of cancelling this. You can see 0 minus 4s is what? Minus of 4s. 4 to 4 you can cancel it. Okay, and what you will get finally? Minus of 2s bracket k minus 4s upon pi plus 2s. Okay, now what you do, just differentiate again d2a ds square. So what will be the case here? So first of all, what we can do, don't find d2 dA ds, first multiply this 2s inside. Okay, just to make it easier one. Wait, here s will not come, because on differentiating minus of 4s only minus of 4 will come, so this s won't be there. Okay, so multiply this minus of 2k there, so minus 2k plus 8s upon pi plus 2s. Now what you can do, now you differentiate with respect to s again, so d2a ds square will be equal to 8s upon pi, 8 upon pi plus 2, isn't it? Because minus 2k differentiation will be 0, 8s will be 8, pi here, and 2s will be 2. So I think this is greater than 0, because the value of pi is what, 22 upon 7. So this is a positive value which is greater than 0. If your d2a ds square is positive or greater than 0, that means we'll have a least. So the first statement we have proved that the sum of their square is least. So this is the least. We'll get the minimum value. The first statement we have proved by this thing. Now we need to prove that the side of the square is double the radius of the circle. Means we have to prove s is equal to 2r, right? Side of the square is double of the radius. Okay, so let us prove this thing. Okay, so to prove the next statement, what we have to do, we have to put dA ds is equal to 0, just to prove s is equal to 2r. So putting dA ds is equal to 0, what we'll get, this statement equal to 0. So I've taken the LCM 2 pi s, and that pi will go that side and it will become 0. Okay, and I've taken minus of 2k here, and I've taken common 2 from these two, so 4s plus pi s, and this minus 2k went that side, 2k, this 2 with this 2 it will be cancelled, so k will be equal to 4s plus pi s. You got the value of k. Now put the value of k in this equation to get your answer, that is s is equal to 2r. So putting the value of k as 2 pi r plus 4s is equal to k. Okay, what is k? 4s plus pi s. 4s to 4s you can cancel, so 2 pi r equal to pi s, pi to pi you can cancel, s is equal to 2r. So that is how this question is proved. Okay, let us come to the next question. If the sum of the lengths of the right angle triangle, that is hypotenuse, and one side is given, means the sum of the lengths of hypotenuse and a side of a right triangle is given, show that the area of the triangle is maximum when the angle between them is pi by 3. That means you are given with the hypotenuse and one side, okay, n of a right angled triangle. That means we have to take these two only, okay, or we can take these two also, but we are considering these two. So we have to prove that it will have a maximum area when the angle between them is pi upon 3. This we have to prove. So let us see, this is very practical question. Let us see how we can prove this thing. I'm considering the hypotenuse as L, and one side, that is base, I'm considering, that is x, and the sum of the lengths of hypotenuse and side is given, so I'm taking L plus x is equal to k. Let's say k, which is a constant term, so L plus x is equal to k, because sum of the lengths of hypotenuse and one side, so L plus x is equal to k. Can we find AB? Perpendicular under root the hypotenuse square minus the base square, just keep it as it is, and from here what will be your L? This will be, L will be what? K minus x, so keep this also aside. Now maximum area, that means we have to use the area of the triangle. So area of triangle is half base into height. Base is what? X, so x we have written. AB is what? Under root L square minus x square we have written. Now we need, see, I'm considering this as A. So show that the area of triangle is maximum when the angle between them is pi by 3. So we need to differentiate this A with respect to x. You can differentiate this with respect to L also, but let us differentiate this with respect to x. So for that our whole equation should be in x. So this is already x, So in place of this L, we can write k minus x. So k minus x the whole square minus x square. Okay. So see, you can do this question in terms of L also. You can find dA dL also. You'll get the same answer. Okay. For that you need to replace this x and this x. Two times you have to replace x. So it's better that we should remove this L and we'll write in place of L in terms of x, and we'll find dx dl. Okay. Now just wait. So here we have the equation that is a in terms of whole in terms of x. We have replaced this L as k minus x the whole square minus x square. Now open the bracket, k square plus x square minus of 2kx minus of x square. This x square and x square we can cancel. We are left with k square minus 2kx. Now this is the equation you have. Now this is a equal to, differentiate this equation. Or one more thing you can do, it would be like easy for you to understand that you just take this x inside, or else what you do, you just square both the sides. So what it will be easy, because you know you have to use product rule and then solving it, so it's somewhat like hectic for us. So you just first of all you take x inside. So a is equal to 1 upon 2 under root. If you take x inside the root, it will be in the square. So k square x square and minus of 2kx cube. Okay, and what you do, take 2 that side, so it will be 2a equal to under root of k square x square minus 2kx cube. Now you square both the sides, so 4a square equal to k square x square minus 2kx cube. Now you differentiate with respect to x. So on differentiating with respect to x, then what you will get, see, you can consider this as fx. This is because you know when you'll differentiate, you'll get 4 2a dA dx. So that is only our area. So you can consider this as fx, that our fx, because our main thing is to differentiate this and get the we have to see the change, that what all change we see when the angle is pi by 3, is it maximum or minimum. That is why we are differentiating. So our main focus is on this expression, not this one. So consider this as fx is equal to k square x square minus of x cube. Or else you would have done one more thing, that you can you can take this 4 down, but not an issue, just fx. Now you differentiate with respect to x, so f dash x will be what, 2x k square, because k square will be as it is, differentiation of x square is 2x, and here what you have, 6x square k. This is your f dash x. What will be your f double dash x? Your f double dash x will be 2k square minus 12xk, isn't it? Because x square is 2x, 6 2s are 12, 12xk. Now from here we cannot like deduce that is it greater than 0 or less than 0, because we don't have the value of x or k. Okay, so after putting the value of x only, then we can just come to the conclusion that it is greater than 0 or less than 0. So for that we need the value of x. How to get the value of x? We put fx is equal to, sorry, f dash x is equal to 0. So let us put f dash x is equal to 0. So f dash x equal to 0, which means 2xk square minus 6k square x is equal to 0, or 2xk square equal to 6x square k. X, 1x will be cancelled, 2 with this 6 you can cancel, 1k will be cancelled, so 3 will come down, k upon 3. You got x is equal to k upon 3. Now put it in your f double dash x. So f double dash k upon 3 will be 2k square minus 12 into k upon 3 into k. This will be cancelled with 4. 2k square minus 4k square. Final answer is minus of 2k square. So minus is there, and k, even if the k is negative, on squaring it will get positive, and finally we'll get a negative which is less than 0. So hence it is, the area is maximum. Now it is, if it is maximum, we have proved. Now we only need to prove that the angle between them is pi by 3. So how to prove that their angle between them is pi by 3? So just see here. So this is how we find cos theta. Let us consider this as theta. So cos theta equal, what is cos theta? Base upon hypotenuse, x upon L. You can go for sin theta also. Okay, so cos theta I am taking x upon L. What is L? K minus x. So k minus x. We got the value of x is k upon 3. Just put k upon 3 upon k minus k upon 3. What is k minus k upon 3? 2k upon 3. This 3 with this 3 you can cancel. You got k upon 2k. K to k 1 upon 2. Cos theta equal to 1 upon 2. When 1 upon 2 comes, cos pi by 3. So that is how theta equal to pi by 3. Okay. Let us do this question. It says an open box with a square base is to be made out of a given quantity of cardboard of area c square. Show that maximum value of volume of box is c cube upon 6 root 3. I'll give you the hint for this question. What you have to do, see an open box with the square base. This is the square base. Okay, this is the box which is open from upside. Okay, so this is the square base, that means this is x. Wait, let me make a fine diagram. This is the cardboard. Okay, and as this is x, this is also x, this is x, and this is, because this is a square, so all the, let us consider h be the height. Okay, this is also x, 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 and x. We are given with the quantity of the cardboard of area c square. That means we need a surface area here, because we need the surface area of 4 walls of that particular cardboard, sorry, open box, and the square base. So c square will be sum of the surface areas of the 4 walls, that is 4hx, because x and h length into breadth, and we have to go for all the 4. So 4hx plus the area of the square in the down, that is x square. So this can be our first equation. Okay, now what we have to prove? Maximum volume. So we need the volume of this cardboard. So this is, volume is what? Length into breadth into height. So the volume of cardboard will be x into h. So x square into h. Okay, now we need to differentiate this v with respect to x, but here we have h with us, so we need to replace this h. So how can we replace? From this equation, take x square that side, so c square minus x square equal to 4hx. So h will be c square minus x square upon 4x. Now put here, so x square into c square minus x square upon 4x. This x and x you can cancel. So finally we got v is equal to, multiply this inside, c square x minus x cube. This is your v. Now what you can do after this, let me give you the proper way how to solve this one. You will get this equation. Sorry, 4 is also there, so upon 4. So what you do, just differentiate it with respect to x, double differentiate it. Your answer, on double differentiation you should get minus, then only you will prove it is for the maximum case. Okay, and from there you find the value of x, and from there on putting the value for the maximum volume, where you will put the values in this one, because we need the maximum volume. For that you need the values of x And how you'll get the value of x? When you put dv dx is equal to 0. So that is how you have to do this question. Okay, so I'm leaving it for you to do. You have to show me. Okay, so that's it for today. We'll see more questions of this until and unless you understand this concept. Okay, so keep practicing. Okay, thank you so much. Have a nice day.